Welcome. In this lecture, we are going to discuss some examples of simple application of division algorithm, and from division algorithm, we will try to find the idea of even and odd integers. Okay. Now, you all know the division algorithm. The division algorithm you all know the division algorithm. It is that if a and b are two integers, that is, if a and b belongs to z and b is greater than 0, then there exists two integer q and two unique integers q and r such that a plus bq equal bq plus r, and r is greater than equal 0 and less than b. Okay. Now let's take here b equal 2. Now let's take b equal 2. Now you can see, if we take b equal 2, then you can see from this line a will be a equal 2q plus r. We put b equal to, so a equal 2q plus r, and from here you can see r will be greater than equal to 0, and you can see b here b equal to, so it will be less than 2. So you can see here, if r is less than 2 and greater than equal 0, then the possible values, therefore the possible values of r is 0 and 1. Okay. Now if r equal 0, then you can see, if we put r equal 0 here, then you can see a equal just 2q, then a equal 2q, and q, you all know that q belongs to z. Okay, q belongs to z means q can take value 0, plus minus 1, plus minus 2, and so on. Okay. Now from this we can see that if here if r equal 0, then a equal 2q. So if we put the values of q in this a equal 2q, this equation, then we can get a equal values 0, plus minus 2, plus minus 4, and so on. Okay. And so we circle even numbers. Okay, I call even numbers or even integers. Okay, even integers. Okay, same thing. Now again putting r equal 1 we will discuss that r can take value 0 and 1. So if we put r equal 1 in the equation, you see a equal to q plus r, this equation plus. So if we put r equal 1 in the equation, a equal to q plus r, then you can see a can take value 2q, then a equal to q plus 1. Okay, now from here you will know that q belongs to z, and q can take value, q can take value 0 plus minus 1 plus minus 2 dot dot dot, etc. Okay, now from this, if q can take value 0 plus 1 plus 2, then from this we can see that a will be equal to like plus minus 1 plus minus 3 plus minus 5 and so on, which are called or integers. Okay, now from the above discussion we can make two definition, that definition 1, right? An integer of the form a equal to q, where q belongs to z, are called even integers. Okay, and second definition is an integer of the form a equal to q plus 1, where q belongs to z, are called odd integer. Okay, now we are going to discuss a simple application of division algorithm. The question is so that the square of an odd integer is expressible in the form 3k or 3k plus 1. Okay, now let's solve it. Now let a be any integer, let a be any integer for a and b equal 3, we get two integer unique integer q and r, such that a equal 3q plus r, where r is greater than equal 0 and less than 3. Okay, now from this you can see that r can take value r equal 0 1 and 2. Okay, so if r equal 0, if we put r equal 0 in the equation, a equal 3q plus r, then you can see a will be equal to 3q. Okay, and if r equal 1, then a will be equal to 3q plus 1, and if r equal 2, then I will take value a equal 3q plus 2. So from this you can see that 3 term 3q plus 1 and 3q plus 2 both can be a odd number. You can see if we take q equal 1, then it will give us that 3. If we here take a q equal 2, okay, then you can see 3 into 2 6, 6 plus 1 7, or integer. And if we take here a 3 q equal 1, then you can see 1 plus 1 into 3 3 plus 2 5. It also gives us the odd integers. So now if we a equal 3q squaring both side, a square equal will be, you can see 3q square equal, see 3 into 3q square. So we can add as 3k, where k equal 3q square, and k belongs to 3 equal k square. Okay, and if we take again when a equal 3q plus 1, then you can see squaring the both side, 3q plus 1 whole square, then you can see 9q square plus 6q plus 1, and we can take common 3, so it will be 3q square, again 2q plus 1. So you can see equal to 3k plus 1, where k equal 3q square plus 2q. Similarly, in case of this a equal, again if a equal 3q plus 2, then a square equal 3q plus 2 whole square will give us 9q square plus 12q plus 4, and taking common, you can see with a common 3q square plus 4q plus 1, and we have to 3 into 3, we have to take 1 in the outside. So here we can see also 3k plus 1, where k equal 3q square plus 4q plus 1. Okay, so thus the square of an odd integer is expressible in the form of 3k or 3k plus 1.